Alright, so let's go through 12-11, which is a question from just last year. Okay, so define electric field strength at a point, right? So you must say that it's a region of space, right, in which a positive test charge experiences electric force. So 2 marks, quite simple. Okay, so for part B, okay, figure 7.1 shows an isolated conducting sphere which has a negative Q charge. Okay, then we are asked to draw 8 field lines, right, to represent the electric field surrounding the sphere. 3 marks. Okay, so 3 marks, how do we actually get the 3 marks? The first mark will actually be allocated for the direction. So for example, right, we know that negative, right, the electric field must be pointing radially inward. So that is the first credit already. Okay, the second is you must draw 8 lines. So they will count on whether you got draw 8 lines or not. So if they see 8 lines, you will be given the second credits. Okay, the third, you must make sure that when you draw the field lines, because it's a metal sphere, means that the electric field line must be perpendicular to the surface. So this is very important. So if it's perpendicular, you will be allocated the third credit. Okay, so that is the easy 3 marks. Okay, let's move on to part 2. Okay, part 2 is back to calculation. So we have this radius of the sphere to be 15 centimeter. So the charge on the sphere may be considered to be a point charge at the center. Okay, now the important thing is the potential gradient at a distance of 40 centimeter from the surface, right, is given as 130 volt per meter. Calculate the magnitude of the charge on the sphere. Okay, so the key thing is, what is the meaning of potential gradient? When you look at the first word, potential, so it's the electric potential, right? Okay, gradient means something like, you know, the differentiation, right? D something, dy dx is the gradient. So of course, if you look at the whole thing by itself, it's actually called a dv dr. So this whole thing is what we call the potential gradient. So this itself is potential. You differentiate, right, is the potential gradient. So if you still remember what is the meaning of dVdr, dVdr is as good as saying the electric field strength. Alright. Okay, so another way you can see that you can look at the unit by itself. So 130 volt per meter, right? Okay, we know that volt is equal to kQ over R. So that's the electric potential formula, right? Okay, divide by meter means it's divide by R. So when you divide by R, right, so the whole thing, KQ right here. So KQ over R. You divide by R, right, it's as good as saying KQ over R square. So when you look at KQ over R square, it's as good as saying electric field strength. So you can see this word, you know, you can look at the potential gradient, or you can look at the, you know, units by itself to see what is the meaning of potential gradient. Okay, so calculate the magnitude of the charge. Okay, so of course I know that, now the electric field at 40 centimeter from the surface is about 130. Since I consider it as a point charge, meaning that all the charges actually emanate from the center. So the total distance from the center all the way to this point is 55 centimeter, meaning it's about 0.55 meter. So I know what is my R already. So the E field is 130. We know that the K, right, 8.99 times 10.9. So my R square, right, so you just put 0.55 bracket the whole thing square. So when you do the calculation for Q, you should be able to get 4.37 times 10 negative 9 coulomb. So that is how you actually get the answer. Of course, if you press your calculator, you realize that your calculator is something like 0.0000. Let me just check. Okay, about 80. 1, 2, 3, 4, 5, 6, 7, 8, 4. So you when you encounter this situation, you need to multiply by 10 to the power of 9, because there might be some numbers at the back that is not shown on the screen of the calculator. So this one you need to be careful, because if you put 4 times 10 negative 9, you will be wrong already. So you just times 10 power 9, you realize that there's some numbers at the back, meaning it's about 4.37. So this one, just take note of this. So for the final answer, you should be able to get 4.37 times 10 negative 9 coulomb. So that is how you actually do this 2023 A-level question.